Good morning, good afternoon, good evening, everybody. Thanks for joining us today for the second webinar of COVID-19 AI series. Today we're going to have 8 speakers, 8 talks. First, Dinggang, we're going to introduce the webinar and the speakers. Dinggang, please.
Okay. So just like Timmy mentioned, this is a MICCAI webinar. The title is Imaging AI-based Management of COVID-19. And Tianming, Guoyan, and I co-organize this webinar. And this webinar actually technically is supported by Guoyan, Chen, Dong, and Sihui. And also organizations supported by MICCAI Society and also Mix China. And this is sponsored by Shanghai United Image Intelligence. So before this webinar, actually we already did publication on May 9. At that time, actually we have 2 1-hour talk. I gave a talk on integrating AI in imaging quantification, identification of COVID-19. And if you are interested, we have the videos in YouTube, also in Bilibili. Second 1-hour talk is given by Wang. He talked about the deep learning on image and graphics, and particularly some applications in COVID-19. And also we have the video provided in YouTube and Bilibili. So yesterday, actually, we gave, basically we have 7 talks from 4 countries, and most of these speakers actually talk about their work published in TMI, 3 TMI, 1 radiology paper, and also Nature Medicine, and particularly Dr. Liu, who is elected chairman for Chinese Society of Radiology. He gave an overview for using AI fighting for COVID-19 in China. So today we are going to have 8 talks, and all the speakers will be from 5 countries. And the first talk will be given by Dr. Zhang, and I will chair his talk, so I would introduce him more in the later. And also, 4 speakers will talk about their work recently accepted in IEEE translation on medical imaging. And also, one of the speakers, Wilo Nissen, coming from Netherlands, he's going to talk about technique or strategies they are going to use to build a Dutch database for imaging and clinical data. And also people from Cambridge and also University of Pennsylvania. Actually, my former colleague, Zhang, and also his collaborator will talk about the strategy used in University of Pennsylvania. So very quickly, just introduce some points for the COVID-19 applications. And I think, for all these applications, it should be like a full-stack imaging AI, starting from continuous imaging, like before imaging, to help protect technicians from COVID-19. When you acquire CT images, immediately AI problem is to quantify infection, and then for all the CT images as well as the clinical information, further testing, experiment data. And the questions you want to answer is how to assess severity. So yesterday I also mentioned actually we have 1 invited review paper in IEEE reviews in biomedical engineering. So from this review paper, we can see most of the papers actually use a UNet or VNet. And this method are used to segment lung or lung lobe or lesions. Here is the infections. And also, for doing all this kind of task, for example, diagnosis, 60% of people use CT, 40% of people use X-ray. And also the method, for example, the question people try to solve is like 50% of papers try to classify between COVID-19 and non-COVID-19. 43% of papers used to separate COVID-19 from other pneumonia. Very few papers actually used to assess the severity for the COVID-19 patient. And 80% of papers use deep learning. The remaining 14% of papers use a traditional machine learning algorithm. And also for all these methods, for example, 57% of methods actually achieve over 90% of accuracy, and 40% of the method achieved 80 to 90% of accuracy. These slides, I just want to show you many papers actually talk about yesterday and also today. They basically focus on the first problem. For example, when you acquire the CT image and the patient is still in the table of the CT scanner, then you want to see where this patient has a COVID-19 or just community acquired pneumonia. So this is a question people ask a lot. But other questions, for example, if a person with a COVID-19, where this person, the COVID-19 is mild or severe, this kind of questions was basically checked by very few papers. And also if a patient with mild COVID-19, then the question is whether this subject still keep stable or not progressing to severe or going to develop to severe. So these two questions, for example, this like COVID-19 to separate them into mild or severe or mild COVID-19, where the subject will develop to severe or not. These two questions actually are very, very difficult actually to answer. And also in the literature, actually, very little papers talking about the task of these two questions. So today, May 15, actually we have 8 talks. I will very briefly mention the 8 talks. The first talk from Dr. Kang Zheng. So he's going to talk about his paper published in Cell, and he used one of the largest data set try to do the diagnosis, and also the long lesion information or features will be correlated with the clinical data to see the correlations. So the second paper actually, I talk about, for example, many people use CT and X-ray. This is paper actually use ultrasound. So the people from Italy and the Netherlands will talk about how to use ultrasound imaging for COVID-19. So third paper actually talking about noise in the labels. For example, if you delineate images, there are some labels, there are some noise. This is very possible because physicians are very, very busy, so they don't have time to very carefully, label the infection lesion for you. So in this way, how to develop a noisy, robust, loss function, try to solve this kind of issues, then you can segment infections, and also you can segment, other lung structures. So number 4 paper actually from Changqing Zhang, Tianming University, collaborating with United Imaging Intelligence, and he used a structural multiple representation algorithm to do diagnosis, actually try to identify COVID-19 from the community-acquired pneumonia. For example, in the training stage, he has 3 steps, and also in testing, then can directly input to the trainer classifier to do this job. So number 5 paper actually from Cambridge, and this paper actually going to talk about how to integrate or combine X-ray with CT, then you can do better diagnosis for the subject. So number 6 paper actually from Shanghai Jiaotong University, Dr. Chen Wang, he collaborating with United Image Intelligence. He is going to talk about using basically different attention strategy and also different sampling strategy. For example, uniform sampling and size balance sample. How can you combine different networks together to do the ensemble learning? And he also applied his method to one of the largest data set in this study, almost 5,000 images to diagnosis using this kind of deep learning algorithm. So number 7 paper actually from Netherlands, as I mentioned before, Lesion. He's going to talk about how to build a Dutch database with imaging and clinical data for all this kind of COVID-19 study. So the final talk for today actually Jim G from University of Pennsylvania. Actually, like I mentioned before, he is my former colleague in University of Pennsylvania, and he and his colleague will talk about how can we integrate computer algorithm to help fighting COVID-19. So this is all the papers for a talk, and if you are interested in the COVID-19 study, and also I want to show you in this slides, actually we have several special issues. I organized the first special issue, I believe, in the engineering journal, actually in the IEEE medical imaging. Also, I work with Tianming and other colleagues for another special issue, actually in the medical image analysis. And this is the third third special issue are involved actually in the pattern recognition journals. And the starting date will be June 1st, and the announcement for paperwork will become very soon. So these are the 8 talks. I will chair the first talk. First talk, as I mentioned to you, actually Dr. Kang Zhang. He will talk about his method developed for the paper recently accepted in Cell. Actually, Dr. Zhang, he published several papers in the Cell for AI applications in different kind of medical images. So Dr. Zhang actually, from what I remember, he graduated from Sichuan University, and then he got MD from Harvard and MIT joint program, and he also got a PhD from Harvard. And then he did latency in Johns Hopkins. Actually, I have a little bit overlap with him, but at that time, we did not know each other. Then recently, he moved to Macau University of Science Technology, China. So Dr. Zheng, it's your turn. I will stop sharing, and then you can share your screen.